Okay, introduction to the new experiment. Well, I've already done all the tests. I'm already done with the experiment. I always do the intros at the end. So this experiment is letting a one mass and a two mass collide into a rubber band and let them go one velocity and two velocity, and then see how much the rubber band stretches. So if I let the one mass collide, and then the same one mass let it collide with twice the velocity, that should stretch with twice the amount. I think both parties agree on this. Both sides agree, and the same with the two mass. If the two mass goes one velocity and two velocity, the two velocity should stretch twice the amount. Now, according to momentum and according to MV, the one mass going two velocity and the two mass going one velocity should stretch the same amount. But according to kinetic energy, the one mass going two velocity should stretch 1.4 more times as much as the two mass going one velocity. All right, so okay, so here we have the results. We have the one mass going one velocity, one mass going two velocity, the two mass going one velocity, and the two mass going two velocity. These are the timings for the one mass going one velocity: 326, 322, 326, 320, 326. Right, between 320 and 326. So half the time would be around 160 and 163. We have 159, so this is the one mass going twice the velocity. 159, 161, 159, 160, 160. All right, so pretty much double the speed. And then for the two mass going one velocity, the same, around 320, 360, so 320, 316, 16, 318, 321. And then twice the velocity, around 160, 165, 160, 162, 159. All right, now this is the amount of stretch. So the one mass going one velocity gave a consistent stretch of 1 centimeter. And the one mass going twice the velocity produced exactly twice the stretch, 222, 1.92. The two mass going one velocity produced a stretch of 1.5, 1.5, 1.4, 1.5, 1.5. When it went twice the velocity, the two mass, it gave a stretch of 2.8, 3, 2.9, 2.9. So pretty much twice the stretch. So both sides agree that the one mass going twice the speed will give double the stretch. Two mass going double the speed will give twice the stretch, and that's correct. But now, the one mass going two velocity and the two mass going one velocity, according to momentum, should give the same amount of stretch. According to kinetic energy, the difference should be 1.4. Well, if we do 2 divided by 1.5, we get 1.33. If we do 2 divided by 1.4, we get 1.42. So yeah, clearly not the same amount of stretch. Go ahead and call it a crap experiment once again. And what are you going to say? you do agree that twice the velocity for the one mass will give twice the stretch, and that's correct. So this case should not be flawed. This case is not a bad experiment, all right? And for the two mass going 1 and 2 velocity, this one should be double the stretch, and it is. So this should not be a bad experiment. It's not flawed, it's correct. But somehow, because this scenario, right, the one mass going 2 velocity and the mass 2 going 1 velocity, right, because they don't produce the same result, of course this one should be flawed and bad. But somehow these are good, but this one is not. So what are you going to say now? Well, whatever, I don't give a shit anymore.